Hello everybody, my name is Salvatore Cosentino from Iwasaki Lab at Tokyo University in Japan. In this video I will be showing you a sample output of SonicParanoid, and will show you how to interpret the output and how the output directory is organized. If you so SonicParanoid, you can find it at this link, and if you successfully installed SonicParanoid, you probably already tested also you also did the test run and got the output from it. So let's now check the output from the sample run, from the test run. So the test run, the input is composed of 4 bacterial proteomes. You have to know that SonicParanoid will create, if you have n input proteomes, it will create n times n minus 1 divided 2 directories, which is the possible number of combination of protein-protein combination for n input proteomes. So let's see now. This is a SonicParanoid directory. I did the test run, and I called the output test output, as you can see in the website. So let's see the structure. So the file, as you since we have 4 input proteomes, we have 6 possible combinations, so we have 1 directory for each combination. And the file you might check in this directory are this species pair. Species pair simply contain all the possible combinations, which in our case are 6 only. And the species txt file contains the input that we gave to SonicParanoid. Let's go now with checking what is inside the directories. For example, this is the output directory for Chlamydia trachomatis and Deinococcus radiodurans. So this is done before the multi-species orthology, and this contains the ortholog tables in the specific case for these 2 species. And the only files you should focus on is this file with the table prefix in the name and SQL table, but more the table one, table dot, in this case table dot Chlamydia trachomatis Deinococcus radiodurans. So it's a simple tab separated text file. So let's open it, see how it looks. So as we can see there are a list. For each list, in each line, there is the first column is the ortholog ID, the second one is the score for that ortholog pair or group. Let's call it group for now. And in this case, the gene on the left belongs to Chlamydia trachomatis, to the species on the left, and this gene belongs to Deinococcus radiodurans. So you can see close to each gene there is a value. That's the score given by SonicParanoid. In this case, it's 1. 1 is the highest score, and remember, we will be calling this kind of orthologs core orthologs. If you go down, you can see that we have also imparalogs in here. For example, this is the score for this imparalog. Sorry, this one, 0.118. By default, the lowest allowed score for imparalogs is 0.05. Okay, done with this part. But when you finish, you want to know the multi-species ortholog groups which are created after the possible combination, the runs for each possible combination is done. And this is inside the multi-species directory. When you go inside the multi-species directory, you should focus mainly on these 2 files. The file you are interested in they have TSV extension, which is tab separated text file. And they start all with multi-species clusters by default. So the one that finish with the all, it means that they use is the one that contains all the possible groups, and it used all the possible ortholog relationships. While the core, the one that finished with core, only used ortholog relationships that had the maximum confidence score. So let's take a look at because it's a TSV file. Let's take a look at the content of this file, and you can open it with your favorite spreadsheet application, which is, for example, Excel or Numbers for Apple, or Google Sheets, or whatever you like to use. So let's see how it looks. Let's not forget we had 4 species in input. Okay, So let's zoom a little bit, maybe too much. Okay, so as you can see, let's enlarge a little bit in here. So the first column is the cluster ID. The second one is how many genes are inside the cluster, says group size. And the third one is probably the most important, in my opinion. It says from how many species the genes come in that are in the cluster come from. For example, 4 means that the genes that are inside the cluster comes from all the 4 species that in this case we had in input. So this number you want to be the same as the input number of input species. Okay, so the way you use it, for example, you might want to sort your data, the file, and based on this column, for example. So let's do it species and group from the biggest. Yeah, so it means all these clusters contains genes that comes from all the species, right? And then down to cases where there are less species. For example, in this case, there are genes only from 3 species. And when there is a star in one of the columns, because then you will find a column for each of the input species. So when you have a gene, then you have it. If you have no entry from the species in the cluster, you will have a star as we've seen before, like for example in here. So this means in this case we had this cluster contains genes from 3 species, nothing from this species, which is Deinococcus radiodurans, and yeah, well, we have one from all the other species. The value next to each species in here is the average score for that given species in that cluster. For example, if we look at this cluster, we see that there are 2 orthologs from Chlamydia trachomatis, with genes coming from Chlamydia trachomatis. So this is an average score. It's 1 because they are both core orthologs. But for example, if we go in here, in the same cluster, right, you can see that we have 3 genes from Globobacter violaceus, and 2 are core orthologs, because the core orthologs are those with only the gene ID. We give no score, because if there is no score, it means if there is no score associated, it means it's a core ortholog. While in this case, this one is 0.14, which is we're pretty much lowering the average score. So this is just another way, another option for sorting your output. If you want, maybe you might want only those that have 1, so you want to select clusters that only have core orthologs, maybe. Yeah, and this is pretty much how the output looks like. We will be working on trying to improve how the output looks like and make it easier for you to understand and hopefully more useful for your research. I hope the video was good and understandable, and hope you will enjoy doing research using SonicParanoid. Thank you a lot. Bye bye.